Today we're going to be discussing how to display quantitative data with the use of Stemplots. So in this lesson we're going to learn how to make Stemplots of using quantitative data, how to interpret and compare distributions with these Stemplots. So the only thing you got to know for this lesson is the Stemplot. However, we're going to be using vocab from the previous lessons on shapes, etc. So like distributions that are skewed or symmetric. Alright, so another simple type of graph for displaying quantitative data is the stem plot. Another name for the stem plot is the stem and leaf plot. So if we want to define stem plot, it's simply a plot that shows the data value that's separated into two parts. A stem, which consists of all but the final digit, and the leaf, which is the final digit. The stems are usually ordered from least to greatest and arranged in a vertical column. Then the leaves are arranged in increasing order out from the appropriate stems. So just to show you an example, this is the caffeine content per 8-ounce serving for several popular soft drinks, and below is the stem and leaf plot. So notice the stems on the left side are 1 through 4, and on the right side you have the leaves, and they're all listed out. Notice that we also have a key, and that key actually lets us know what the data represents and how to interpret the stem and the leaf. Alright, so how do we make the histograms? So first you want to make your stems. So separate each observation into a stem consisting of all but final digit and the leaf, which is the final digit. You want to write your stems in a vertical column with the smallest at the top, and then you want to draw the vertical line at the right of the column. So make sure to not skip any stems, because even if there's no data value for a particular stem, you don't want to skip it because it actually tells you meaningful information about the data. So for step 2, you want to add the leaves. So you want to write down each leaf to the right of its stem, and you can separate the leaves either by spaces or commas. Generally I use commas, however you can separate the numbers by spaces. Now next you want to order the leaves. So you want to order them from smallest to greatest, so in increasing order out from the stem. Now I generally do steps 2 and 3 at the same time, so as I'm adding the leaves I'm also ordering them, so it makes it simple to do it, to take care of two in one step. For the last step you want to make sure you add a key, because this key has to explain in the context of the word problem what the stems and the leaves represent. Alright, so let's look at an example. To become a president of the US, a candidate does not have to receive a majority of the popular vote. The candidate does, however, have to win a majority of the 538 electoral votes that are cast in the Electoral College. The table shows the number of electoral votes in 2016 for each of the 50 states and the District of Columbia. So make a stem plot of these data. So we got the data for each state as well as DC. So for the first part, I went ahead and listed the electoral votes from the table just to save us some space. So again, we want to make the stems here. The smallest number in this case is 3 and the largest is 55. So notice that the stem for 3 is 0 because 3 is the leaf, and the rest of the number, there is no rest of the number, so we just say 0 for the stem. The stem for 55 is 5. So we're going to start with our columns 0 through 5 for the stems. Next we want to add the leaves and order them. So let's look at adding the leaves. The leaf for 13 is 3 and the stem for 13 is 1. So we're going to go ahead and order the leaves. So I'm going to cross out, starting with the 0 stem, cross out the numbers. So if I see 3s, well, I see 2, 4, 6, 8 3s. And then for 4s, I see 5 4s, so I cross them out and I list them. I see 3 5s, so I cross them out and list them out. 6 6s, and then 3 7s. Alright, so I also see 2 8s, and last but not least I see 3 9s. So for the 1 stem, I need to look for tens numbers like 10, 11, 12, 13. So I see a bunch of 10s. I see 4 10s, so I'm going to cross those out. I see 4 11s, cross those out. 1 12, 1 13, and 1 14. I also see a 15, 2 16s, 1 18, and that's it for the teens numbers. I don't see any 19s. Now we're going to the 20th numbers. So I got two 20s and two 29s. For the 30 numbers, I see a 38, and that's it. I don't see a 40 number, so I'm going to skip that stem. I see a 50 number, 55. Alright, so we got our stem and leaf plot. Now make sure you add your key in. The key has to explain in context what the stems and leaves represent. So here we're talking about the electoral votes. So in our key, we simply provide an example. So if we have a 1 followed by the vertical bar followed by 5, that just means a state with 15 electoral votes. Alright, so take a look at these two examples. So one of them is actually the original that we did in the previous slide. The second one is known as a stem and leaf plot with stems being split. So notice that a lot of numbers in the original on the left stacked around the 0 stem. So if we want to get a better picture, we can actually do what we call splitting the stems, which means splitting each individual number stem into 2. So in this case, the values for leaves 0 to 4 can be placed on the first stem, and then the values ending in 5 through 9 can be placed on the other split stem. So notice that there are two zeros. So for the first 0 on the right stem and leaf plot, we went from 0 to 4. And then for the second 0 in the stem and leaf plot, we went from 5 to 9 and listed out those digits. And this gives us a better picture of the distribution. And that's our splitting the stems. So some tips to consider before making a stem plot. Notice that there are no set number of stems to use. However, you don't want to use too many or few stems, because then it will be difficult to see the true shape of the distribution, or at least a shape that you can actually interpret. So a good guideline though is to use 5 stems as a good minimum. If you split the stems, make sure that each stem has an equal number of possible leaf digits. So for example, 0 to 4, that's 5 numbers. 5 to 9, that's also 5 numbers. So make sure that each of them have an equal number. So use this. When the data have too many digits, you can get more flexibility by rounding the data. So if you had some decimals, you can round it to the nearest whole number, for example, and then actually do the stem and leaf plot from the rounded data. Alright, let's look at another example. So we're going to use this electoral votes split stem plot given to the right to answer these questions. So what percent of states get 10 or more electoral votes? Alright, so we want to interpret this stem and leaf plot. So what we want, if you notice that we want the states that are 10 or more. So there are 21 states that have 10 or more electoral votes from the stem and leaf plot. We have a total of 51 because 50 states including the District of Columbia, and then if you do this and times it by 100, you get 41.2%. Now if you look at the shape of the distribution, it kind of looks skewed right. So if you look at, for example, this sideways, then you have this kind of shape, which looks skewed to the right. If you kind of look at it sideways like this, then it's skewed right. Alright, so now let's look at part B. If we want to describe the shape, well, we said it's skewed right. There's a single peak at the 0509 stem, and there are 2 clear gaps, one from 29 to 38 and the other from 38 to 55. And what we're doing is essentially looking at okay, so what we were saying is that these gaps here, so from 29 to 38, that's this gap right here, and from 38 to 55, that's this gap right here. Alright, so let's look at the outliers. Well, it looks like 38, which is Texas, can be considered an outlier, as well as California 55. Alright, so we're going to compare distributions with stem plots. If we want to compare two distributions, we use what we call a back-to-back stem plot. So essentially, you have the leaves on each side. So you have leaves on the right side, leaves on the left side, with the column for the stems in the middle. So let's look at an example of how this looks like. So, of the many species of oak trees in the United States, 28 grow on the Atlantic coast and 11 grow in California. How does the distribution of acorn sizes compare for oak trees in these two regions? Here are the data on the average volumes of acorns in cubic centimeters for these 39 oak species. So part A wants us to make the back-to-back stem plot. So I'm going to go ahead and put the table on the top right so we can reference it. So we want to make the back-to-back stem plot. So we're going to start with two vertical lines because we have two distributions here. We have the Atlantic coast on one side and California on the other side to compare the distributions. Now I'm going to actually start with the key here so that we can kind of see how to do this. So for the California side, notice that we have a bar on the left side, the stem, which is 5, the bar on the right side, and then 9, which is the leaf. So this represents 5.9. For the Atlantic coast, you have the number 3 on the left side, the vertical bar, 0, which actually represents the stem here, and then the vertical bar. And this actually means 0.3. So we'll show you more how this looks like in a second. So actually, if you look at the smallest numbers, you have 0 for the stem, and you have 17 for the largest stem. So we're going to list out the stems from 0 through 17. Now let's start with the Atlantic coast. So for the Atlantic coast, we have 0.3 for the first number. So then we simply put a 3 to the left of 0. We have 0.4 for the next number, so 4. Then 0.6, which is 6, 0.8, 0.9, and then you have, that's it for the 0 point numbers. Now you're at the 1 point numbers, so 1.1, you have 4 of them. Then you have 1, 1.2, 1, 1.4, and 1, 1.6. So you see how this works. The numbers, the digits are listed outward from the stem. Now you have 3 1.8s, 1 2.0, 1 2.5, and so on. We go ahead and list the rest of them. As far as the right side is concerned, for California we got a 0.4, so we put a 4 there. We got a 1.0, so 0, and then we list out the rest of them. Okay, so that's our distribution. So now let's compare the centers. So if we look at the California oak tree species, they tend to have larger acorn volumes. So the center for this is roughly around here. So around this area, we can kind of, if we cut it in half here, that's about the center. And then Atlantic coast, the center is around 1.6 to 1.8. So maybe somewhere, we know that it's around this area. If we were to cut it, the center is around there. So generally it seems that the California species have larger volumes than the Atlantic coast. As far as the distributions, they do seem to be different. So for the Atlantic coast, the distribution is skewed to the right and single peaked. So if we do this, it has that peak, and actually it kind of goes down a little bit like this. But overall, it does seem to have that one big peak, and then it's skewed to the right, or to the skewed to the right. I apologize. So yeah, so it'd be skewed to the right. It's kind of backwards, remember, because of it's on the left side instead of it being on the right side on the table. And then if you look at the California, well, it is also skewed to the right. If you kind of look at it that way, but it has two, it actually has two clusters. So like one around here, and then you kind of have another one around here. So there's two clusters there. And there's a large gap between 7.1 to 17.1. So there's a big gap here. So it's clear that 17.1 is that outlier. All right, so go ahead and pause the video and try it first. All right, so we're looking at data involving pairs of shoes that teenagers own, broken down by gender. So we got 20 female students and 20 male students from a high school. So we want to make a stem plot, and we don't want to split stems in this plot. All right, so I went ahead and listed the data for the females since that's what we're interested in doing the stem plot for. So let's start with a vertical line, and then list out our stems. So the smallest number, or the smallest stem number, is 1, and the largest stem number is 5. So we're going to list them out from 1 to 5. Now we want to go ahead and list out our leaves. So we have 3 13s, 1 15, and 1 19. We have 1 22, 2 23s, 1 24, and 2 26s, so I crossed those out. 1 30, 1 31, 1 34, and then 1 38. We got 1 49, we got 2 50s, a 51, and a 57. So we got our stem plot for females. Now let's start with our key. Let's not forget our key. So 2 with a vertical line with a 2 after it represents a male student with 22 pairs of shoes. This actually should say female student since we're doing this for females. So we'll change that to female with 22 pairs of shoes. All right, so let's look at the shape of the distribution. So there seems to be a clear peak in the data, and there's a cluster from 13 to 38. So from here to here, essentially, there's this cluster, and then another from 50 to 57. So kind of this generic cluster here. All right, so if we compare the spreads, the male distribution is not very spread out, so we should probably split the stems in order to visualize the distributions. So if you look at the male data, there's not much spread. If you look at these two numbers from 4 to 58, there's not much spread when you compare it with the females, which is from 13 to 57. Alright, so now let's compare both distributions using the split stem and leaf plot. So the females typically own more shoes than the males. So the centers of the females is roughly around here, so we'll say about 26. The center for the males is about 7. So if we were to kind of do it, it would be roughly around here. So if we cut it in half around there, it's about 7. So then if we compare them, clearly the male center is lower than the females. Also, the spread of the males, as we mentioned earlier, is actually less than the spread of the females. The males go from 4 to 38, the females are from 13 to 57. And both distributions actually seem skewed to the right. So if we were to draw it, they look skewed to the right. Alright, so let's summarize. So stem plots are another simple way to represent quantitative data. Remember that stem plots divide the data into leaves, which is the final digit, and the stem, the other digits. We talked about how to make stem plots, in which the stems are split, and how to compare distributions by making back-to-back stem plots. Alright, so the next lesson is going to cover histograms.